Welcome to the debate. Today we're delving into a technology that's poised to really redefine the future of global logistics, the digital twin, or DT, as it's applied within smart ports. Ports are, the choke points of world trade, these critical nodes linking vast maritime transport to very complex land networks. And frankly, they're buckling under the pressure to maximize efficiency, to hit sustainability targets, and just to manage the operational complexity. So this virtual replica, the digital twin, is being touted as the essential virtual brain to manage it all.
And that premise right there, that the DT is essential, that's really where our disagreement begins.
Absolutely. So our central question is this: is the widespread, holistic implementation of digital twins the definitive, inevitable solution for achieving sustained efficiency and substantial energy savings in modern ports? I'll be arguing that the DT is the transformative, foundational backbone that modern ports simply cannot afford to ignore.
And I will argue that the aspiration, it vastly outstrips the current reality. The substantial and I think often overwhelming barriers related to cost, to data complexity, and to fundamental security risks, they currently limit the digital twin to being an expensive, highly specialized tool for elite hubs, not a practical necessity for the industry at large.
Well, my position is that the functional capabilities of the digital twin provide really the only way forward for a system of systems as complex as a global port. I mean, when you combine the DT with advanced artificial intelligence, we're talking machine learning and deep learning algorithms, it creates this unparalleled system that just fundamentally enhances resilience and intelligence across the whole supply chain. This is not some incremental improvement, it's a paradigm shift. Port management moves definitively from being reactive, using historical data to explain what went wrong, to being truly predictive and prescriptive. The system knows what's about to happen, and it dictates the optimal course of action.
You do paint a very compelling picture of theoretical peak performance, but this completely neglects the practical financial reality on the ground.
Times, and that's what increases capacity. Crucially, the DT's core value is achieving holistic efficiency, optimizing the port as a single unified system. It facilitates optimal resource use, intelligent linking of every single port process, and that is a direct path to achieving massive sustained energy and cost reductions. This backbone offers three non-negotiable requirements for modern trade: distinct situational awareness, powerful data analytics, and a unified platform for multi-stakeholder collaboration.
I see why you think that, and I agree the conceptual value is immense. But the technical and financial hurdles required to deploy a DT at the scale you're describing are frankly overwhelming right now, especially for the small and medium-sized ports that make up the vast majority of our global trade infrastructure. I mean, you have to look at the context. Ports are systems of systems. Their complexity and operational heterogeneity are, they're orders of magnitude greater than even the most sophisticated industrial facilities.
But complexity doesn't negate the need for a solution, it amplifies it.
Implementation demands colossal upfront investments in IoT sensors everywhere, sophisticated AI analytics, robust cloud infrastructure. For many small and medium-sized enterprises, the SMEs operating within these port ecosystems, this capital outlay is just prohibitive. And what's more, general industry findings suggest that the cost of widespread automation sometimes outweighs the benefits, at least in the short term. And even if they could afford the hardware, the data problem is still there. Integrating legacy enterprise resource planning systems, all these different IoT devices, proprietary software, it immediately creates data silos. This fragmentation just undermines the real-time synchronization your digital twin needs to even function. So the virtual brain concept, it just keeps hitting the wall of messy, real-world data.
That's a fair point on the integration challenge, but we have to look at the architectural evolution of this technology. This isn't some new, unproven concept. It's technology that has been successfully scaled for increasingly complex environments. Let's just, briefly look at the history. Digital twins started as specialized tools for managing relatively simple, isolated systems. Think early NASA spacecraft or advanced aerospace manufacturing. From there, the technology matured and was successfully applied to more complex environments like smart cities.
And that transition is critical, I'll grant you. Moving from a single manufacturing floor to an entire urban area, a smart city, that is a huge leap.
Exactly. And the port is the natural next step, though. Yes, it's significantly more challenging. A port is functionally intertwined with both the smart city, dealing with urban infrastructure, traffic congestion, and the global supply chain. This very interrelation necessitates a system of systems, DT architecture, to get that complete, coordinated view.
I'm not convinced that historical analogies really addresses the sheer magnitude of the integration problem in a port. The challenge isn't just the number of sensors, it's the number of independent, often competitive actors that have to share mission-critical data in real time. A port's DT has to unify vast amounts of static data, like the structural integrity of a quay, with highly dynamic data from terminal operators, shipping agents, railway companies, government customs agencies. The port call process alone involves securing transactions, nautical services, managing specialized labor.
Right, but the DT provides the trusted platform to achieve exactly that. The whole objective is to establish a high-fidelity virtual interface that unifies data from all these operators to achieve a collective awareness.
But attempting to create a single interface that combines all this data requires harmonized digital data exchange and protocols. And those standardized frameworks are what we currently lack across the global logistics industry. The moment you introduce data from a legacy rail system and try to interface it with a proprietary crane management system, the complexity risks fragmentation, not unification. Without robust, globally enforced data standards, the unified DT platform, it just remains an abstract, very costly goal.
Investment from energy efficiency. The evidence is compelling in several key operational scenarios that are only possible with a holistic DT view.
I agree. Sustainability is a critical driver. But let's talk numbers. Where does the justification for this multi-million-dollar capital outlay actually come from?
It comes from optimizing the supply chain itself. Look at just-in-time arrival. DT modeling, using virtual arrival time protocols, dynamically manages a ship's speed based on real-time port congestion and berth availability. This actively reduces fuel consumption, sometimes dramatically, and it avoids that energy-intensive process of anchoring outside the port for hours, even days. That's a systemic saving right there.
That is a measurable saving. But I'd argue that more targeted ship-to-shore integration systems can achieve that virtual arrival optimization without the need for the full, vastly expensive digital twin infrastructure. You're asking for the whole package when only one part of it might deliver that specific gain.
But the DT facilitates interconnected efficiencies that simple tools can't. Take dynamic lighting. A DT-controlled management system monitors the entire port's lighting, ensuring lights are only on when vehicles or personnel approach. This isn't a small saving. The Valencia Port Authority, after implementing a system like this, reported saving nearly 80% of the energy consumed by that infrastructure.
80%? That is impressive for a specialized application? Yes, but let's weigh that against the total implementation cost. I'm sorry, I just don't buy that the incremental savings from ship arrivals and dynamic lighting, no matter how large locally, justify the systemic cost and risk of overhauling an entire port's operational infrastructure.
But those are just two visible examples. The largest savings often come from predictive maintenance. The DT evaluates real-time stress and usage data across all equipment, optimizing the trade-off between maintenance schedules and maximizing utilization. This minimizes the risk of catastrophic, energy-intensive failures. These systemic, layered savings are what ultimately justify the high initial investment. It moves the port from being a cost center to a highly efficient machine.
I still disagree on the cost-benefit analysis. Implementing a holistic DT requires not only that huge initial investment, but massive ongoing operational costs to keep the models accurate and synchronized. And now let's address risk. You're migrating nearly all operational intelligence to a highly interconnected, cloud-based system. This dependence increases vulnerability exponentially. If the complexity or a cyber risk leads to a systemic failure, the cost and disruption to global trade will far outweigh any savings from dynamic lighting.
We're not introducing vulnerability, we're building resilience. The DT is designed to mitigate complexity by functioning as the facilitator of multi-stakeholder governance. By guaranteeing a high degree of data integrity, and providing a constant, high-fidelity virtual mirror. It achieves the situational awareness necessary for coordinated, safe decisions.
Okay, that sounds nice in theory, but how can a mid-sized, financially constrained port justify that initial capital outlay? You've confirmed the technology is ready, but you haven't defended its economic feasibility for the average port.
Because the strategic necessity has to override the short-term financial pain. The alternative is obsolescence. Ports are becoming too complex, and the demands for net zero operations are too stringent to continue with piecemeal, siloed systems. The DT is a foundational investment that pays dividends through efficiency. Furthermore, stakeholders can use this unified platform for automated decisions like optimizing truck routing to reduce urban congestion, with total transparency. This collaboration is built on shared visibility, allowing data analytics models to make decisions autonomously and safely.
But that shared environment is precisely the greatest vulnerability. Digital twins rely on continuous, real-time data collection. This constant synchronization across multiple competitive stakeholders, many using different, potentially unsecured cloud infrastructures, makes the entire port system susceptible to organized cybersecurity threats and data breaches.
But robust systems are being developed, often leveraging advanced cryptographic security or even integrating things like blockchain ledger technology to ensure data immutability.
I'm familiar with those mitigation strategies. And while they can enhance data integrity, we still have to consider the challenge of data sovereignty and competitive privacy. You're asking shipping lines, terminal operators, and cargo owners, who are competitive entities, to share their real-time operational intelligence on one platform. The risk of intellectual property loss or exploitation of bottlenecks by an adversary expands dramatically. Without resolving these foundational trust and security limitations, the virtual brain is arguably a risk multiplier for critical national infrastructure, not a safeguard.
I maintain that digital twins represent the necessary pivot from reactive management to intelligent, predictive operations. They fundamentally enhance both competitiveness and sustainability by optimizing the port as a cohesive system. The documented energy savings and the proven ability of DTs to handle this kind of complexity demonstrate that the technology is ready. Implementation is a strategic imperative for any major hub looking to remain relevant.
And I agree. The ambition of the DT to create a unified, intelligent control system is strategically laudable. However, the practical barriers of crippling cost, the systemic integration challenges with legacy infrastructure, and most importantly, the unresolved data governance and cybersecurity risks currently outweigh the benefits for the majority of port environments. Until these foundational issues of complexity and security are standardized and the cost of entry is substantially reduced, the holistic port digital twin remains an expensive, specialized technological aspiration, not the universal, practical necessity you claim it is.
I think that the material clearly illustrates that the discussion has to pivot from asking if the technology works, which it demonstrably does, to how to manage the risks and resources necessary to implement it in a hyper-complex environment like a global port.
And that how remains the massive, unanswered economic and security question that prevents its widespread adoption today.